Continuing with our transformations unit, today we're going to take a look at rotations. By the end of this lesson, I want you to be able to rotate points in the coordinate plane and write those new locations down. A rotation is when an object turns around a point. The object remains the same distance away from that point, but at a new angle. So our black point here, if it gets rotated, say 90 degrees clockwise, it's saying it's turning 90 degrees in that direction. And about the origin is kind of the point where it's turning from. So what you can actually do is make a vertical and a horizontal line connecting the points. So if I draw a vertical line there, horizontal line there, I could have gone horizontal first and then down with the vertical. It doesn't matter. But when I rotate 90 degrees clockwise, what happens is the three spaces that was a horizontal line now becomes three spaces of a vertical line. Our one space of a vertical line becomes a one space horizontal line, and that becomes our new point. So you could see that it's almost like you turned that L 90 degrees to the right. You moved the black point to that top red point using the origin as kind of the point that you are spinning from. Just to review a few things, remember clockwise is going that direction, and counterclockwise is going to be the opposite direction. If we take a look at a couple examples, rotate point A 90 degrees clockwise around the origin. We're not always going to rotate around the origin, but those are always the ones we like the best. 90 degrees clockwise. So we're kind of using this point, the origin, to help rotate or turn that point A. So you can draw a vertical line and a horizontal line connecting the 2 points. And rotating clockwise 90 degrees, we see there is 2 horizontal spaces. That becomes 2 vertical spaces. And then the 3 vertical becomes 3 horizontal. And that new location, A prime, is going to be at 3, 2. If we look at the next one, they're telling us rotate the same point, but counterclockwise around the origin. So it's still around the origin, but now we're going counterclockwise this direction. If we draw in that vertical line and horizontal line connecting the points, we can see that the horizontal distance of 2 becomes a vertical distance of 2, and then the vertical distance of 3 becomes a horizontal distance of 3. So our new point, A prime, is down here at -3, -2. What we actually come up with is a little rule. And you might not have noticed here, but our original point was -2, 3. And looking at the new points, there's some similarities between the original to the new one. And that's a rule. If you're a visual learner, you should be good. If you need kind of equations, this is probably more your style here. So when we're rotating 90 degrees clockwise, we typically have the point XY. What happens the rule says you switch your x and y spots, and then you take the opposite x value. So if the x was a positive, now it's a negative. If the x was a negative, it's now a positive. When you're going counterclockwise, the rule says you switch your y and x, but now you're taking the opposite of y. So those are just two rules that you would want to memorize to know what's happening to those if you're going 90 degrees about the origin. If it's about another point, you can't do it that way. So let's take a look at some more examples. Rotating a point 90 degrees clockwise around the origin. So 90 degrees clockwise is in that direction. I can draw the point at the origin, draw a vertical line and a horizontal line. I think most of them I've been going one way, but it works regardless. So here I have 3 spaces that are horizontal, so that'll become 3 spaces vertical. Then I had 4 spaces vertical, and then that becomes 4 spaces horizontal. That one looks funny, but you'll see that it'll end at the same spot because the 4 vertical become 4 horizontal and then 3. So it's almost like that L shape rotated to here. If we followed that whole rule, this was at 3, 4. The new one is at 4, -3. So you can see you switched your x and y and then took the opposite of x. So 4, -3. Whether you're a visual learner or not, you can remember that the rule says to switch the x and y, but take the opposite x. So this is our new point. What if we're trying to rotate 180 degrees? So we don't have a rule for it yet, but we know 90 degrees can be rotated twice. So let's take a look at that. Clockwise about the origin. So here's the point that we're rotating. Clockwise is this way. 180 degrees, I think we'll be fine doing. So we have 2 horizontal, 2 vertical. So then that, to go 90 degrees, would have been 2 horizontal, 2 vertical. Another 90 degrees would be 2 horizontal, 2 vertical. So you could see I rotated it 90 degrees twice. Well, we know 180 degrees forms a straight line. So what you actually have here is the 180 degree rotation. This new point was at -2, -2. So we started at 2, 2, and then ended at -2, 2. That might have been a bad example because they still had 2's on there, but what the rule says, when you go 180 degrees, whether you're going clockwise or counterclockwise, since you're going straight across, it's the exact same. You keep the x and y in the same spot, but you take the opposite of each. What about this one? Rotating 90 degrees counterclockwise around 2, 2. This is one of the challenge problems. So we're not going around the origin. Now it's at a different point. So I'm going to draw that 2, 2 in. We still want to connect it with some sort of vertical, and horizontal line. Counterclockwise, we know is going this direction. So from this point, instead of having 3 horizontal spaces, we're going 3 vertical spaces. Instead of having 1 vertical, we have 1 horizontal. That new point ends up at 3, -1. There is no rule to do these when it's not around the origin. So those XY, opposite X, those rules only work when it's about the origin. But if you're able to kind of visually see this, you're pretty well off because these are challenging problems. What about if we're rotating 180 degrees clockwise about the point 1, 1, 1, -1? So 1, -1 is right there. Whether we go clockwise or counterclockwise with 180 degrees, it doesn't matter because you end up in the same spot. But since they said clockwise, I'll go ahead and do that. So the 3 vertical spaces will now be 3 horizontal. The 1 horizontal is now 1 vertical, but then you would do it again, going from 3 horizontal to 3 vertical, and then 1 vertical to 1 horizontal, landing at 0, -4. And if you notice, if I were to connect these two, it's forming 180 degrees right through this point by rotating it 90 and 90. Well, how do we do it with shapes? It says 90 degrees clockwise around the origin. I'm thinking in my head 90 degrees clockwise. My rule says you switch your y and the x, but then you take the opposite of x. Origin is that starting point. If I connect point C, going 90 degrees clockwise. So instead of going 2 vertical, I'm going 2 horizontal. Actually, I would do the 1 vertical to go with the 1 horizontal, and then 2 horizontal to match up with the 2 vertical. C prime ends up right there. Well, where is that? It's at 2, 1. If we looked at our original C, it was at -1, -2. So our C prime, following the rule, says you switch the x and y. So the -2 goes here. And then the x, you take the opposite. So as we're looking here, I rotated 180 degrees, and rather than starting over again, we're going to plot that correctly right here. 90 degrees going this way would have only been 1 rotation. So this is my C prime. My original B is at -3, -2. So my B prime, switch the x and y, but take the opposite of our x. So that would be at -2, 3. My original A was at -3, 3. So my A prime, switch the x and y, but take the opposite of the x, lands at 3, 3. So I think when it comes to moving shapes, it's probably a little easier to actually follow the rule. And you could see that got spun, rotated 90 degrees going clockwise. What about 180 degrees? Our rule says you take the opposite of x and the opposite of y. So our A was at -3, 3. Our B was at -3, -2. And our C was at -1, -2. So our new ones, we're taking the opposite of each. So this is at +3 now. This is at -3. For this one, this is at +3, and this is at +2. This one's at +1, +2. So when we plot those 3 points, and we connect those, you could see it got spun like directly about the origin. If I were to connect for 180 degrees, A to A prime, B to B prime, and C to C prime, they all connect where they spun, which is at the origin. And that's when we're going 180 degrees. Taking a look at this one, I want you to go ahead and pause the video and see if you could rotate it counterclockwise 90 degrees about the origin. So the rule here was you switch the x and y, but take the opposite of y. So our original points right here. So our new ones should be at -3, -3, +2, -3, and then 2, -1. -3, -3 is right there. 2, -3 is our B prime. And then 2, -1 is your C prime. And you could see that that got rotated 90 degrees counterclockwise. Working backwards, we're trying to figure out which point did the triangle rotate around and by how many degrees. Now looking at this, seeing that it ends up being completely upside down, we should already be thinking it went 180 degrees. And we learned that if it goes 180 degrees, we should be able to connect the points, and that'll reveal where their point that they rotated about were. Always when I get to that third one, it never wants to work right. So what we see here is all of them intersect here at 0, 1. So they rotated around 0, 1, 180 degrees. And it doesn't matter if we say clockwise or counterclockwise, because 180 degrees, you end up at the same spot. What about this one? Noticing that it's not completely upside down. We should be thinking in our head 90 degrees. Also looking at the direction, you should see the way the object gets turned that way to the right. So we're thinking it's going to be 90 degrees clockwise. But from what point? Around what point? So you kind of want to make the little L connecting points, and they should all intersect at the same spot. If I draw the C and connect, and then I connect the B's with the same kind of L, you notice those aren't hitting at the same spot. If I'm going this way, they're not hitting at the same spot. So then I'm going to, instead of doing this one with the C, I'm going to go this way. And now let's try it with the B. Can I have it hit at the same spot? Yeah, right there. Can I connect A to that point and then to the A prime while making it 90 degrees? Let's test that theory out. You look, yeah, that's 90 degrees. So the point that it was hitting at is here at 1, -2. A lot of different stuff thrown your way. Definitely some challenges, some visual stuff, some memorizing of like a rule of sorts. Hopefully we're somewhere in this range. Hit me up with any questions. I'll see you soon.